I hope everyone's doing well today. Today we're going to continue our states of matter and kinetic molecular theory PowerPoint. We're just going to really learn one key topic. So these next three slides, they've got this different guard background because you don't need to know the specific information on these slides. But this first one says this thing called Boyles Law says pressure and volume are inversely related. In other words, if the pressure goes up, the volume goes down. If you squeeze a balloon, the pressure inside gets higher while the volume of the balloon gets smaller. The next thing is called Charles's Law, which says volume and temperature are directly related, which says if you were to, say, heat that balloon up, then its volume would increase. This also says your temperature for this has to be in kelvins, and we'll talk a little more about that in detail. But kelvins, this is on page 3 of your reference tables, that kelvins are equal to degrees Celsius plus 273. Because the nice thing about the Kelvin scale is it never goes negative. The third thing is something called Gayluss Principle, which says that pressure and temperature are directly related. So if you have a container where the volume can't change, for instance, let's say you had a sealed up aerosol can and you increased the temperature, the pressure would go up in that can. That's why all aerosol cans say do not expose to fire, because the pressure will eventually get so hot that the can explodes. Once again, your temperature must be in kelvins for this. But we don't need to know each of those individual gas laws, because we have something called the combined gas law, because it literally combines Boyle's law, Charles's law, and Gayluss Principle. And it says that P1V1 over T1 equals P2V2 over T2. And this equation is found on page 3 of your reference tables. Your temperature must be in kelvins. And what this means, this is your pressure, your volume, and temperature under one set of conditions. And on the other side, it's your pressure, your volume, and temperature under a second set of conditions. So if you know your initial set of conditions and you know two of these three things under your new set of conditions, you can find what the third variable is. And once you plug in the numbers, it just becomes a very straightforward case of algebraic substitution. You just have to remember that your temperature needs to be in kelvins, because kelvins can never go negative. And if you think about it, volume can also never go negative. You can't have something like, you can take a balloon, and if you cool it down by putting it in the freezer, the volume will get smaller and smaller and smaller, but you can't cool it down so much that it occupies less than no space. Negative volumes don't make sense. So make sure that you always use kelvins. If you do not use kelvins, you'll get it wrong every time. And if we check on our reference tables, if we look on page 3, then you should be able to see right here is the equation for turning things into kelvins from Celsius. I don't know what this is doing here. And then right underneath it, you have your equation for the combined gas law. So we're going to look at a couple of sample problems. So this first problem says 45 liters of gas has a pressure of 500 millimeters of mercury at 30 degrees Celsius. If it is cooled to 15 degrees Celsius and the volume is 35 liters, what is the new pressure? So first of all, in this problem, you'll see that we're starting with a volume, a pressure, and a temperature, and then we've got another temperature and another volume. We're looking for another pressure. That's a good sign that we're using the combined gas law. So we just need to kind of identify what these different numbers are. It says 45 liters, that's a volume, and we'll call that volume 1. This is the first one we get to. Then 500 millimeters of mercury. This is a pressure. We'll call that pressure 1. And 30 degrees Celsius, we'll call that temperature 1. If it's cooled to 15 degrees Celsius, well, that's temperature 2. The volume is 35 liters. That's volume 2. What's the new pressure? P2. So all we need to do now is plug into our equation and solve. So the combined gas law says that P1, 500 millimeters of mercury, times V1, 45 liters, over T1. Now that's 30 degrees Celsius. So we need to take 30 degrees Celsius plus 273, and we'll find that that's 303 kelvins. Now it's going to equal P2, which we don't know, times our second volume, 35 liters, over our new temperature, 15. And 15 degrees Celsius plus 273 is 288 kelvins. So now, to solve this, we've got our variable that we don't know, P2, and we've got this. There's several different ways you can do this. You can simplify the left side of your equation and divide this, and then divide everything on the left side by that, or you can just cross multiply. And cross multiplying is probably the easiest way, where essentially you say P2 times 35 times 303. So we're going to get 10,605 P2 equals 500 times 45 times 288, which is 6,480,000. And so P2, you take 6,480,000 and we divide it by 10,605, and we get 611. And since our first pressure was in millimeters of mercury, our new pressure is in millimeters of mercury. And that's our answer. Now, there's one more thing I need to teach you, and that's something called STP. STP just means standard temperature and pressure. And this is just some sort of set of conditions that scientists have come up with that they are calling standard conditions or standard temperature and pressure. You can find what those conditions are by going to page 1 of your reference tables. And in this first box up there, you'll see that standard pressure is 1 atmosphere or 101.3 kilopascals or 760 millimeters of mercury or 760 torr. And standard temperature is 0 degrees Celsius or 273 kelvins. So in other words, this would be like if you were standing at sea level on Topsail Island, for instance, and the temperature outside is exactly freezing, 0 Celsius, 32 Fahrenheit, you are at STP. And that's just the set of conditions that scientists have come up with. So let's look at one more example, and then I'll have you do some problems. A 1.5 liter balloon has a pressure of 190 kilopascals at 22 degrees Celsius. What is the volume at STP? So if we look at this, well, this is V1, this is P1, and T1. What is the volume? V2, we don't know. And then standard temperature and pressure, well, that's going to be T2 and P2. So we plug into our equation, P1 times V1 over T1. So 190 kPa times 1.5 liters over 22 degrees Celsius plus 273 is going to be 295 kelvins. Don't forget to put it in kelvins. That's going to equal P2 V2 over T2. And V2, we don't know. Now for our pressure units need to stay the same. We can't start changing units in the middle of the problem. So we need to find standard pressure at 190 kilopascal in kilopascals. And standard pressure in kilopascals is 101.3. So we're going to use 101.3 kPas. And standard temperature is 273 kelvins. So we do a little bit of multiplication. 295 times 101.3. So that gives us 29,833.5. V2 equals 190 times 1.5 times 273. And that equals 77,805. And then V2, we take those and divide them, 29,883.5. So V2 is 2.6 liters. All right. So hopefully you're kind of getting the idea of how to plug numbers into this and solve it. What you'll find next in Google Classroom is a few problems for you to try on your own. Good luck.